Welcome to class, everybody. It's that time again. We've got fun, exciting things we're going to do today. I'm going to ask you a few questions with the Pull Everywhere software. So if you could be thinking about these 7 items when I come to ask you, then you'll have at least some time you'll maybe thought about it already. I'm going to ask you the number of hours per week that you do homework on a typical week. Number of hours per week that you watch television, including YouTube, Netflix, that sort of thing, your GPA, your age, the number of hours per week in a typical week that you exercise, the year you are in school, freshman, sophomore, junior, so forth, and your gender. Okay, so when we get to that point in the lecture today, hopefully you'll have had a chance to think a little bit about that. And in other words, we're going to collect some data today, and we're going to analyze the data and hopefully gain some insights about you guys. So before we jump into what we're doing today, are there any questions that you guys have about homework or class format or schedule or anything like that? Has anybody looked at the homework yet? It's pretty straightforward. The first one, mostly multiple choice. It's very easy to get 100% on the first homework if you do it by when? Thursday at midnight. I guess that's actually Friday. Is that Friday at midnight? It's midnight Thursday. 11:59 on Thursday. 11:59 p.m. Make sure you get it done by then, and you'll be able to get full credit. Quiz number 1 is very similar to the homework, and will also be fairly straightforward and I think easy to do, but that's due on Friday at midnight. So I am going to review briefly the big picture of what it is that we're doing in statistics. Now I know there's a video online. I'm going to find out how much of you watched this video and paid attention, and I'll do that by asking a few questions with Pull Everywhere. But here's the big picture for statistics. We have populations that we're interested in, and we want to know about the characteristics of the population so that we can make decisions in terms of what we want to try and sell to the populations, if you're thinking about this in the business setting. So the characteristics of a population have a special name, and I want you guys to tell me what the characteristics of a population are called. So go ahead and type your answers in, submit those, and we'll see who did the homework. We've got 11 responses so far. The responses in very helpful. Give you another 30 seconds or so to get your responses. So that's about half of you guys. 33 out of, I just counted, there's 61 or 62 of us. Okay, well, let's pull up the responses and see what you guys said. Let's look at the... group of people or things that are in a certain distance of each other. Nope, that's not it. Distribution. Nope, that's not it. Feature. Nope, that's not it. Measurement. Nope. Observation. Nope. Okay, here we go. Parameter. That's the right answer. And it's like a handful of you got that right. Quality, sample size, size and density, statistic, theta, union, variable, and so forth. Okay, so let's come back over here to the big picture. And I guess it's good we asked that question because it shows me that we don't quite see the big picture. Now this is really important when you're working on statistics. There's a lot of information. There's a lot of detail oftentimes. And it's very easy to get lost, mired down in the details. And you're saying, well, hold on, what on earth are we doing? Well, if you take a step back and think about what I've got up here and what I'm about to tell you, that will be very helpful. So a population has characteristics called parameters. And parameters are so important that they usually take on the form of Greek letters. So mu, sigma, pi. I think this textbook uses pi. Some textbooks will use p instead of pi. Let's see, what else we have? Theta, and so forth. Anytime you see a Greek letter, think parameter, characteristic of a population. So we want to know about these things because that's something that we can use to make decisions about our business processes or other things that we're doing. So if we want to know the characteristics of a population, how can we find out what the value is for, say, the mean, mu, the population mean for a population? There's only one way to do it if you have a population that is any population. The only way to find the value of a characteristic or parameter is to do a census. In other words, you sample the entire population. You say, okay, I want to know how much money people have in their bank account. So I ask the entire population, how much money do you have in your bank account? And when the entire population has responded, then I calculate the average and I get the value of mu. Okay, so is that useful information, how much people have in their bank account? Yeah, sure it is, because if they have a lot of money in their bank account, then I might try and sell them some stuff. But if they don't have money in their bank account, there's no point in trying to sell them stuff because they can't buy it unless they use credit or something like that. Well, what's the problem with the census? The back. Okay, if it's a population that's really of interest, then when you take a census, it's going to take a long time because it's probably a big population. Like the United States has a population of 300 million people. Every 10 years, the United States government does a census. How long it takes for them to do the census? Anybody? It takes a whole year. And when they do the census, they start at the beginning of the year, they end at the end of the year. And the idea is to find out how many people there are, all the different characteristics the government's interested in, where they live, what their income is, how many kids they have, so on and so forth. What's the problem with the census if it's a really big population? By the time you're done with the census, the population has changed. So it's inaccurate. Another problem is it's extremely expensive to do census, especially of that magnitude. So what do we do instead of a census? We still want to know what the characteristics of the population are. We do someone said a survey or take a sample. Okay, so we're going to take a sample from the population, and when we do that, as long as we have a representative sample, then the characteristics of the sample can tell us information about the characteristics of the population if we know how to use something called probability. So if we have a knowledge of probability, that allows us not only to take a representative sample from the population, but it also allows us to make statements about how likely the characteristics of the population are given the characteristics of the sample. So what are the characteristics of the sample called? Should we ask another question? Yeah, let's ask another question. Characteristics of a sample. And again, these are the things that we're going to use to make statements about the population characteristics. Think about it. Responses are, and then we'll talk about it. Okay, so that's 34, 35. I'll give you another 20 seconds to put your results in. Okay, so we've got 39 people that responded. We've got, let's just sort these. Feature, focus, gender, inference, measurable, observation, probability size, statistic. It's like the most popular answer is statistics or statistic. And then there's a few other responses that are not the right answer. The right answer is statistic. So characteristic of a sample is called a statistic. And these things are usually written with Roman letters. X bar, for example, matches up with mu. S matches up with sigma. P for pi. T, and so forth. And we can write down the formulas for the statistics that we're interested in, the population statistic and the sample statistic. Sometimes they're basically identical. For example, if we write mu and we say that's equal to what, we're just going to take the summation of all of the observations or all of the individuals in the population, and we're going to divide that by the size of the population. That's the sample, that's the population mean. Right? Makes sense? Just add up the values for everybody in the population. That's what this summation sign means here. This capital sigma, it just says take x1 plus x2 all the way up to x. So capital N, divide that by capital N. Okay, so that's the population mean. The sample mean, x bar, has almost the same formula. Summation of the x's divided by n. This time it's a lowercase n. And so what that means is we've taken a sample. We don't have the entire population. We take a sample, but Otherwise, the formula is basically the same. Okay, standard deviation is a little bit different. If we have sigma, that's going to be the square root of the summation of xi minus minus mu. That is squared divided by capital N. So again, a population characteristic. If we are able to calculate sigma, that means we have already calculated mu. So we have a sample for the entire population. We know what mu is. We can then use that. We say how far away from mu is each of the observations that we have in the population. That's all we're doing. We're taking that distance, but then we're going to square the distance so that when we add these things up, we're adding up positive numbers. That way we don't get cancellations. And that is the population standard deviation. The sample standard deviation is very similar. Take the square root of the summation of the xi's minus, well, do I know what mu is? If I'm only taking a sample, I don't know mu. I don't know the population mean. So I'm going to estimate that with x bar. And x bar comes from the sample. So I'm going to square that. And then I'm going to divide. Instead of dividing by n, I lose a little bit of what we call freedom by estimating mu with x bar. So I have to pay for that. And I do that by dividing by a slightly smaller number, n minus 1. Okay, so we've got the population value, the sample value, and they're very similar, but the formulas are slightly different. Okay, anytime you've got a parameter that you're interested in, there's going to be some way to estimate that with the sample value. And that's really what we're doing here. We're going to say if x bar, my sample value, is close to maybe a theoretical or hypothesized value for mu, then I'm going to be able to say, using what's called inference, or rather statistical inference, and this is what we talk about when we say statistics. When we're doing statistics, this is the part that we're doing right here. We're saying, I don't know what mu is, but I'm going to make an educated guess. That's one way of doing this. I'm going to say if mu is some number, then I can use probability in my sample to see how close x bar is to the value that I am hypothesizing. So maybe you've heard of the scientific study, and we'll talk more about this later on. But scientific process says, let's make a hypothesis and then go and collect some data and see if the data supports the hypothesis. So if I were to say, I think the average bank account content for Drexel undergrads is $1,000. Okay, I don't know if I just pulled that number out of thin air. How am I going to check that? I'm going to say that's my hypothesis. That's what I think it is. So I'm going to go out and I'm going to ask a bunch of students, hey, how much money do you have in your bank account? And if I do that randomly in such a way that I have a representative sample from the population, and I get back, so if I'm saying mu is equal to 1,000, and I get back x bar is equal to 950, I'll say, yeah, it's not exactly 1,000, but is it close? Is it close enough for me to be able to attribute the difference between what I saw and what I expected to randomness? And that's a big part of where probability comes in. Probability is the study of uncertainty. So all we're doing is saying, okay, let's collect some data. Is it close enough that the difference we see can be attributed to randomness or uncertainty? Or the alternative is the difference that I see, $50, that might be due to the fact that that mu is not 1,000. Okay, and so all we're doing in statistics is collecting data and saying, is the data close enough to some value that comes from somewhere? And I don't know where it comes from all the time. Maybe it's an expert. Maybe it's just popular opinion. There could be lots of different places that this comes from. Okay, so that's what we're doing, and we'll get more into the details. But basically, what I'm going to do is say how much variability is there in the X bar. How much? I take a sample. I get all sorts of different numbers. How much variability is in that? And does that variability allow me to make statements like, yeah, it's close enough? And what do I mean by close enough? So we'll talk more about those things. But this is the big picture. And this statistical inference is where all the details lie. In fact, it's really going to be the same story told over and over and over again, but the details are going to be a little bit different. So if you can get this big picture in your head and say, okay, I'm interested in the characteristics of the population, the parameters, I can estimate those with the statistics, the characteristics of the sample, and now I just have to figure out, well, what's the characteristics of the sample? What's the formula? Turns out X bar is going to have a probability distribution. So X bar is a random variable. That means it's going to have a distribution that goes along with it. So I need to understand what the distribution is. Okay. Again, we're going to get into these details more, but when you get mired down in the details and you're saying, what on earth is going on here? Take a step back and say, oh, here's the big picture. This is the test statistic we're interested in, X bar, or S, or P, or whatever it is. What kind of distribution does it have? Now I want to be able to make statements with probabilities associated with those about the true values of the parameters. Okay, so I've got another question, but I'm not going to ask it to you with poll everywhere. I'll just ask, what is the characteristic of an individual called? That's called a variable. So we've got characteristic of an individual is called a variable. Why is it called a variable? Because it changes. For every single individual in the population, it could be a different value. Now, it's not always going to be a different value. If you're talking about gender, for example, then you've got male and you've got female and maybe something else. But you're going to have repeats if you have more than 3 people that you're polling. Okay, so it's variable because it's not constant, and it's the characteristic of a particular individual. And so what do we mean by when we say a random variable, do you think? A random variable is what I just said, except for there's randomness. In other words, if I'm going to take a sample and the next person that walks in the room and I ask them whatever it is I'm interested in, the characteristic I'm interested in, it's completely random to me. In other words, I don't have any basis for explaining what it's going to be, what the answer is going to be. So there's uncertainty about the outcome. And anytime there's uncertainty, we have probability involved, we have randomness involved, then we have a random variable. Okay, and we'll talk more about that as we go through the course a little bit more. But it is a very important kind of foundational notion, this whole idea of randomness. And okay, so what do you think the most important characteristic of a population is? Any ideas? Well, I think it's the one that you're interested in at any given moment. But in general, we like to look at the first moment, or the first moment. Maybe I shouldn't use that terminology. But the first moment is the measure of center. In other words, where is the middle? And if we're going to measure that, we have three different notions. We've got the median, we've got the mean, and we have the mode. And there's all sorts of other variations on these things. What's the difference between the median and the mean? The mean we already wrote down the formula for. We said just add up all the data points, divide by the number of data points that you have. That's the mean. That's one way to represent what's going on in the middle of the population or the sample. Yeah. So for the median, then. Okay, so the median then is the data point that's in the middle. So you would take all of your data, you would sort it, and you'd say which one's in the middle. And that's going to be the median. Okay, we're going to deal a lot in this class with the mean. And there's good reason for that. But you do want to be a little bit careful about what the mean means versus what the median is. And I'm going to ask you guys a question to help you understand this a little bit better. So I did my graduate work at Duke University, which is in North Carolina. And when I arrived there, my wife and I had just graduated from college and went straight into a PhD program. My wife worked for a couple of years and decided that she wanted to go to school and get a master's degree as well. So she got a job, or got into a master's program at UNC, which is just 8 miles from Duke, and we lived in the middle, and I rode my bike, and she drove her car, closer to Duke, and so she got into this program, and she went in to take her, I think it was the first semester, they had a statistics course that she was taking, and we got in there, and they said, you know what? All you people that are majoring in city planning, you should really be majoring in geography. Because, well, they didn't say why. They said, somebody raised their hand and asked why. And they said, well, the average starting salary for geography, that's why. So I want to ask you guys, what do you think? What do you think they meant by that? What's the average starting salary for geography majors? And don't look this up or anything. Just give me your best guess. And remember, this was at UNC, University of North Carolina. And it's actually kind of closely related to city planning, I think, a little bit. But geography, you're like, you got names of rivers and lakes, capitals, mountain ranges, all sorts of stuff like that. What do you think? What's the average starting salary for an undergraduate UNC geography major? Note that I'm asking you the average, not the median. Okay, so we've got 47 responses. We'll hold out just a little bit longer. Anybody having trouble getting answers to go in here? All right, there's 50. I guess we'll take that. Two. Okay, so about 20,000, 0, 2 million, 10,000, 35,000, 40, 40, 50, 55, 60. Oh, I forgot to tell you how old I am, because that would probably affect your guesses here. We've got 65, 250, 200,000, 100,000, 95,000 golden rupees, 83,000. So this was back in 2001, I guess, when they asked this question, and so I'm going on off of those numbers. Turns out the correct answer is about $250,000. So UNC geography majors, starting salary is about, just put it on a little line here, and we'll say here's 250K is, and we'll call it mu because it's a small enough population that you can actually do the calculation very easy. So what's going on? I think my wife switched to geography. Well, it was too late because she wasn't an undergrad. This was for undergrads. Well, what's going on with this? One person said 250. Why did you say 250? Because there's a guy named Michael Jordan who graduated from UNC in geography as an undergrad. But he left, remember back that far, 1983. Left, he was taken third in the NBA draft, but he was only a junior, so he hadn't graduated. And he did come back and graduate a few years later. By the time he came back to graduate, he was an NBA superstar. He was making, upon graduation, about $60 million a year. So everybody that is down here making peanuts, that's where almost everybody else is. And, the median salary was probably like, we'll say right here, median is about 35K if you're lucky. And then Michael Jordan's way out here. In fact, we'll put a little break. Michael Jordan's out here at 60 million. So if we calculate the average, the mean, then all of these data points get the same weight. They're all weighted by 1 divided by n. All right, come back and look at the formula. We have 1 over n goes to all of them. So, does he use geography? Yeah, all the time. He was like, every week it was like a new venue, new city, new country. He's traveling all over the place. The geography probably came in handy, but is he a geographer? No, so we probably really should throw that out. But it's a fun, interesting example of what's going on between the mean and the median. So if we take the median, then it doesn't matter the value. You have $60 million way out here. That actually doesn't come into play. The only thing that comes into play is that it's the maximum value. Could be 600 million, and it's not going to change the median any more than it being 60 million or 6 million. So the median is just the point in the middle. So take all of the points here, however many there are, and count them all and pick the one in the middle.
So on this line graph, this is only 250,000.
Yeah.
Okay.
Yeah. So if you took out Michael Jordan, then the mean and the median would be pretty close to each other. Okay. So this tells us something about something called skewness, and this is a very heavily skewed in the positive direction data set. In fact, if you see skewed things like this, usually there's a red flag that you need to investigate, and you'd say, oh yeah, Michael Jordan, he's not your typical geographer. If you want to get an average salary of $250,000 as a geography major, you also need to be very good at basketball. Okay, so that would be a better qualification to take into account. Okay, so that's interesting. Are there other examples you can think of where the median is a better measure of center than the mode? If you pay attention to real estate, we're talking about the representative measure for housing prices. You never use the mean. It's always the median house price. Why? People like Bill Gates, Michael Jordan, and these people that have giant, enormous houses, just use that way out here. The average is not representative of most people. So the median in that situation is used properly. But having said that, in this course, we're going to use the mean a lot, like almost all the time. And there's good reason for that I'm not going to get into today. Okay, so let me just talk about inference. There's a couple of different ways to do the statistical inference, and I've mentioned one already, and it's called the frequentist approach, or the frequentist paradigm. Sometimes it's called classical statistics. And the idea here is, again, to come up with some notion of what the parameter values are from either expert or historical data or popular opinion over the years, and so forth. And then you go out and you collect data and you say, does the data support a theory? So you think about the scientific method, you've got a theory that says, well, this is what everybody else thinks, but I think that the parameter value is something different. This is new and innovation, and that's kind of how science works, and we make decisions and learn things. But then what do I do? How do I prove this theory? I go and I collect a bunch of data, and I say, does the data support my theory? And if you think about it, that's really kind of backwards, isn't it? Because I've got my theory. If I go and collect some data, and I know that there's potential for randomness, it's possible that I randomly find data that supports my theory. And if I don't find data that supports my theory, what am I inclined to do? I mean, imagine it's a really good theory. I'm inclined to throw the data out, go and find some more data, collect more data. If I collect enough data, eventually I'm going to find something that supports the theory. And that's the real danger in the frequentist approach to statistics. If you're right and you're not bent on proving your theory, then there are other arguments against it. But there's another approach called the Bayesian statistical approach. And Bayesians go the opposite direction. They say, let me collect the data, and then I'll just see what the data tells me. Now, there are criticisms that you can levy against the Bayesians as well, because they oftentimes have notions themselves about the values of the parameters beforehand. And so these people, for the most part, get along now, but for years and years and years, they didn't get along, and because they have different foundational or fundamental beliefs about parameters and how you treat parameters, I should say. But what we're going to do in this class is the frequentist approach. If you understand the frequentist, it's not that big of a stretch to understand what the Bayesians are doing. Okay, so how are we doing on time? 40. All right, I'm going to ask you guys 7 more questions all at once, and then we're going to take our break. So this is really important. I've got 7 questions, and you need to put them in separated by a comma. So you see down here it says HW, comma, TV, comma. Just put it in that same format. Don't put the quote marks. But I want to know, number one, how many hours per week, this is on a typical week, do you spend on homework? How many hours per week do you spend watching TV? That's number two. Number three, what's your GPA? Number four, how old are you? Number five, how many hours per week do you exercise? Again, typical week. Number six, what year are you in school? Freshman, sophomore, so forth. And number seven, what is your gender? Okay, so put that in homework. So some number, 5, comma, or 50, or whatever it is, comma, number of hours for TV, comma, GPA, and so forth. And when you get that put in, then go ahead and take a break, and we will start back up in 10 minutes, so that'll be 10:52. Okay, so you guys are all back? Everyone back? Good enough. During the break, somebody asked me about these formulas here, so let me just be clear what's going on here. Anytime you see this capital sigma, not anytime, but most of the time in this class anyway, that means add up a bunch of stuff. And then, so if you were to say, what does this formula right here mean? This says take the square root of, take the first x, so xi means an observation, and so the first one of those is going to be x1, and I'm going to subtract from that mu, and then I'm going to square it. And then I'm going to add, I'm going to do that again, but for the second observation. So x2 minus mu quantity squared. Do that for all of these things. And divide by capital N. And then take the square root. Okay? So I just want to make sure everybody's clear on what that means. Any other questions about this? Yeah, so I really should write this, the summation, and I didn't write it because sometimes you leave it off, but there's an index that goes with the I. So if I take the summation, I really should be writing the index. We're saying take from I equals 1 up to n, xi. So start with x1, then x2, and so forth. Yeah. Okay, so what are we going to do now? We are going to open up Excel, and we're going to make some charts and some plots and do some calculations. And this is going to be a great opportunity for you guys to get some exposure to software. And so whatever data that we've just collected, I will post on Blackboard, and you can go back and look at it, and I'll post all of the work that I'm doing as well. And I'll try and make sure that I narrate as I go through and do all of this stuff, so that you can go back and you can follow along. And in fact, I'll put the data set up immediately so you can pull it up and you can work on it as well as we go through this. So 57 responses. We're going to export this. Okay, so you can see all the responses right here, and we want to export this to, we're going to download it as a comma separated value file. And I will clean it up real quickly before I post it on Blackboard so that you can see what's going on here. Okay, so here I've got the time at which this was created. I have the phone number that sent it in, if it was sent in by a phone number, and then I have registered participant, and let's see what other information I have. Screen name, and then how I got the data. So this is all information that maybe at some point I might be interested in. So I'll just leave that in the, well, I don't know if I'll, actually I won't post that part. I'll get rid of all this stuff. But if I did, I could treat this as a variable. Are more people using a phone, or are they using a computer or website to get on? That's another variable. So really I've collected more than just seven variables. But what do I need to do here? I need to convert this into an Excel file, but first I've got some problems. So I need to edit the data. And a big part of statistics is making sure your data is in the right format. So people that put hours in here, like 3 hours, 5 hours, that's not going to work. I'm going to have to change that, just get rid of the hours. And in fact, I'm going to do it quickly. Control R. That's not working, so I want to find and replace. Control F. Find, replace. I want to get rid of hours. And I don't want to replace it with anything, so find the next one. And replace that. Replace. 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 Okay, what else do I have in here that I need to fix up? So this response here, is that, can I use that? I've got a 7, but I don't know what the 7 means. So sometimes you just have to throw data out. So we're going to throw that one out. Delete that. Okay, what else have we got? Less than. Let's see. Somebody did. Make this a little bit bigger so you can see what's going on. Okay, so the instructions were to use commas. It looks like somebody used a semicolon here. So I've got to get rid of that, and I'm dealing with numeric data, so I can't have less than, so I'm just going to put 10, 2, and I'm going to note that the data has been altered. Okay, 3.01, 20 years old, I don't want that part, comma, comma. So if there's a bunch of semicolons, I would just do the find and replace. Around 10, and maybe I should have been a little more explicit with my instructions not to use things like that. That's fine. Okay, sophomore, I know that's got to be edited. If I had a large data set, I wouldn't want to do all this. And let's see what else we have. 10 to 12, I can't deal with that with my data, so I'm just going to change that to an 11. 3 to 4 is going to go to 3.5. Any other problems here? 24 to 28 is going to go to 26, just taking the average. Okay, 2 is going to go to 2. 12 is going to go to 12. 6, 8 goes to 8. Senior male. Okay, that's good. These little tilde things, they're not any good. Got to get rid of those. 7.5. That's going to go to a 4. Anything else in here? And actually, maybe it'd be easier to do all this editing after I save this thing or convert it to a Excel file. So I'm going to go here and say save as. Just find somewhere to put this thing. class survey, what's today? 10.01.2018. And I want to save this as an Excel file, and when I do that, it's going to make me fix this up a little bit. Actually, I want to convert this now to, let's see, data, text to columns. So I've got all these data cells here that have text. I want to convert that to columns. So I can either do a fixed width, which I don't want to do. Instead, I'm going to go here and say I've got tabs, separation. I want a comma separation where there's a comma. And then I can scroll down here and see, does that give me what I want? Okay, so I still have some approximately's and things like that. But I think it's going to be easier to deal with this once I have it converted. So I'm going to say, let's just go ahead and do that. And finish it. No, I don't want to do that yet. Let me put in a few extra columns here. So I'm going to just insert. And if you don't know how to do any of this stuff, what I'm doing, then you can go back and watch and see how to do it. This is useful stuff to be able to do in Excel. So again, text to column, delimited. Next, I want to go comma. If I went space, what would happen? That clean it up as well. Okay, so let's not do the space. Let's do commas. Okay, next, and then finish. Okay, so here is the first response, which is what? Homework. So we'll call that homework, and then we have TV. Clean this up a little bit. What else did we have? What was the third one? We had age. No, GPA. And then we had age. And then we had what was it? Exercise. Well, EX. And then we have grade. We call it grade. It's not really grade, but then we have gender. Okay, so what else do we need to do to clean this stuff up? We just go down here. We've got that's going to go to 15. This is 1.5. What is that? 3 to 4. That's going to be 3.5. And Microsoft is trying to think for me again. So I'm going to change the format of this from a date to a number. And I have no idea what happened with that, so we'll probably end up throwing that out unless somebody wants to tell me what they meant by that. Okay, so we got 27.5. Again, I'm just taking averages where I don't know what they are. So I think this would be, it said March 3rd, right? March 4th, so 4, so this should be 3 to 4. So we'll change that to 3.5. There we go. And we'll just go with that. Maybe it's right, maybe it's wrong. I don't know. Here we got 4. And so what else do we have here? We've got some people who put GPA, so we'll just put it 3.2. 3.84. Everything else looks okay in the GPA column. And then we're going to come over here. These are both 19. It's not 29. 19. 19. Exercise. Okay, so we have three daily exercise. That's 3 hours a day. Every day of the week. Is that supposed to be weekly? So should I multiply that by 7? Speak now or forever hold your peace. So we'll call that 9. And let's call it 0. Female. And pre-junior. Male, and we don't have that one, so what's going on here? 63. The age is 63. I don't buy that. I'm going to put that as 19. And okay, so spending the time that you need to is sometimes time consuming, but that's okay. What do we have here? Grade 2017. That means that when you started, so you're a sophomore. So I admit I'm taking some liberties with this, but that's okay. Okay, so I'm going to make this so you can see it better. Then I'm going to post it on Blackboard, and you can bring it up and follow along if you like. And let's see, do I want to... What's going on with this thing? Okay, I'm going to get rid of the rest of this stuff if I can. I don't know what's going on with my thing. We're not going to need this data, and so let's just save this. Let me come over to Blackboard. I'll go with the week 2 folder. Not sure why the internet is not cooperating. Anybody else having trouble with the internet right now? Okay, well, then I guess we won't post this for everybody to see. But this is a big part of statistics. Data collection, data cleanup, getting it in the right format so that you can use it. And what else do we need to do here? Well, let's go ahead and sort the data by let's do it by grade first. Okay, so yeah, we've got other problems. This is going to be sophomore, so let's just copy this and paste it wherever there's soph. Junior is going to go here. Pre-junior. Let's make sure I got the same format for everything. senior, and then we've got a whole bunch of sophomores. So I'm going to highlight all of this stuff just so I get rid of the caps. Second year, what does that mean? Sophomore, junior, sophomore, sophomore, so pre-junior. And that one we don't have, so. Okay, so that's one way to do this. Next thing I'm going to do is sort by gender. I'm going to come over here. I'm going to click sort, and then I want to sort by gender. And again, the reason I'm doing this is so that I can give the same exact value for all of these things. So I copy the one that I want, and then I highlight everything and paste it. Girl, that means female. So then I'm going to do the same thing for the males. And I don't know why it didn't sort these females. Okay, so everything is in order, I think. Nope, it's not. Hold on. Somebody put a space in there, and then I copied it the whole way through. Like I said, cleaning up data take a lot of time. Okay, so what's the first thing we want to do here? We've collected our data. We now want to look at a visual representation of the data. So we can do what's called a dot plot, which is kind of like a histogram. Hopefully you saw that already. So I'm going to change the name of this screen or the sheet to let's call it age. And we're going to come up here and we're going to make what we call a count variable. So I'm going to say count. And first thing I need to do in order to find out how many 17-year-olds, 18, 19, 20, and so forth, first thing I need to do, and this is kind of the back door way of doing this, but I need to get this in order of age. So I'm going to come over here. I'm going to say, let's sort the data again. And this time I'm going to say, let's sort the data. Why is it? Okay, let's go like this. Highlight all the data, and then we'll say data sort. And I want to do it by age. And I want to go smallest to largest. And I say OK. And so now I've got someone that's age 11, which I don't believe. My guess is that should be 11 here, and they should be a sophomore. And so age is gone. Let's just throw that one out. And now I want to say, in the count variable, I want to know how many do I have that are age, whatever the age is right here. So I'm going to say count equals, so this is in cell I2. I say if D2 is equal to D3, then whatever the value is in I2, that's the current cell, I'm going to add 1 to that. And then I say comma, and it says, so if the statement is true, then do I2 plus 1, otherwise else, comma 1. And so I say enter, and I only have one person who doesn't have an age here, So I'm just going to leave that, but I'm going to copy this and just paste it in here. What's going on here? Okay, so and this is I'm having all sorts of trouble today with Excel. This formula is right and it's not working. So if, let's try it right here. If that thing is equal to that thing, then I want to take I2 plus 1, comma 1. All right. I'm just going to copy this all the way down here to the very bottom. And I'm going to put it in, and I'm going to say, okay, how many 18-year-olds do I have? Well, there's 3 of them, right? 1, 2, 3. And this needs to be shifted down. Okay. So I've got 3 18-year-olds, and I can look here and I see I've got 3. All right, so I can come over here and say, oh, I won't do that yet. But how many 19-year-olds are there now? So I'm just counting how many there are. It turns out there's 31 19-year-olds. And how many 20-year-olds are there? I've got 12, 21, there's 4, 22, there's 4, and 29. Looks like there's 1. Okay, so if I want to look at this in a pictorial representation, a dot plot, I'm going to highlight count, and I'm going to highlight age, and I'm going to go up here to insert, and I'm going to do give me a dot plot. Okay, so this is what you might call a frequency distribution, and if I want to, I can let's see, let's see, x-axis, right click on that, format, excuse me. Format axis, I can come up here and change it. So the minimum right now is 0, but I know I don't have anything that small. So I'm going to change this to, what do we say, 17? Let's say 17. Okay, so I can look at this picture. I can use a computer, and I can get a real good idea. Now, it's not super fast the way that I did it, but other software packages, and I think even Excel has other ways of looking at pictures like this quickly, but you see what's going into this in the background. You got to count how many you have in each of the categories, put them into the groups, and then you can print look at a graph of this thing. So we have 19. That's going to be what? Is that going to be the mode? We talked about the mean and the median previously. We didn't talk about the mode, but this is the mode. The mode is the point that happens the most often. So most of you guys are 19, right? That shows up the most. Okay, so if I want to make a frequency distribution, then, and this is what you call a frequency count. If I wanted to make a frequency distribution, here's how I would do this. Let's just leave that over here. I'm going to come back up here and I'm going to say, here's my frequency distribution. So I'm doing this in cell K1. So then in K2, I'm going to say I've got 18-year-olds, I've got 19-year-olds, I've got 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. So now I'm just going to come over and say how many 18-year-olds do I have? Well, there's 3. I'll put that in. How many 19-year-olds? There's 31. 20-year-olds, I don't remember, so I got to scroll down here. 12, 4, 4, and 1. We got 12 here. We got 4, 4, and then all the way down here we've got a 1. So the rest of these are zeros. And so this is what we call a frequency distribution. It's just a count of how many observations we have in each of the categories. So if I want a relative frequency distribution, how do you think I get that? What's a relative frequency distribution? Well, relative to the total number of observations we have, what's the proportion? And so to get this, I'm going to come down here and I'm going to say this is equal to the sum. So I'm in cell L14. And I say this is equal to the sum. I'm just going to highlight all of the cells above that up to L2. So from L2 to L13. And I see that I've got 55 data points that I'm dealing with. Okay, so the total is 55. So if I want I'm going to move the label for the frequency distribution over to L. And for M1, cell M1, I'm going to put the relative frequency distribution. So what does this mean? This means take the value from L2, I'm putting this in M2. So there's 3 18-year-olds. I'm going to divide that by L14, which is the total number, and I get about 5% of the class is 18. Now I want to do the same thing for 19-year-olds, and if I just copy the formula and paste it, make this a little bit bigger. Is that too big? That's too big. 200%. Okay, that's better. What happens if I copy the formula from M2 and place it in M3? Well, I get the exact same formula, but it's dividing by L15 instead of L14. I wanted to divide by L14. So it turns out if I come up here and I edit this formula and I say I want column L, but I want row number 14, and I always want L14, I can lock that so it's not a relative cell reference but an absolute cell reference by putting $signs before the L and before the 14. So now when I copy and paste that, I get in cell M3, I'm going to get cell L3 divided by cell L14. So notice I didn't do anything to the first part here, to the L3, or rather the L2. I didn't put a $sign in there. That's because I want that to be a relative reference, not an absolute reference. When I copy and paste it, it's going to give me the right thing. So here I'm going to copy this, I'm going to paste it all the way down, and you can see that I get a frequency distribution now. I've got 5% in the 18-year-old category, 56% are 19-year-old, 21% are 20, and 7% are 21, 7% are 22, and then I have almost 2% of the class is 29. Now notice if I take the sum, so this is cell M14, I'm just going to take the sum, so sum of everything above that up to M2, that's going to add up to 1. That's always going to happen if I've done this correctly, because a relative frequency over all of the possible values has to sum up to 1. You can think of it as a probability if you like, or a representation of the probability. Okay, so that's interesting and it's useful. But another thing that we're going to use in class is what's called the cumulative frequency distribution. And so cumulative, what does that mean? It means we're adding stuff up as we go along. And so the notion we're going to use for cumulative is we're going to start on the left side, and as we go to the right side, we're going to add up the values as we go, or the counts as we go. And we're always going to do that. We're going to start with negative infinity, we're going to go to positive infinity, and we're going to add up the counts, or the frequencies as we go along. So the cumulative frequency for 18-year-olds means 18 years old or less. And that's just going to be equal to 3 in this case. The cumulative frequency for 19-year-olds, what does that mean? That means 19 or less. So it's going to be whatever we had before. So I have in cell N3, I'm going to say that's equal to cell N2 plus the frequency for 19-year-olds, so plus L3. So I've got 34 that are less than or equal to 19 years old. Okay, I'm going to do the same thing for 20-year-olds. I'm going to take what I previously had. So in cell N4, I have N3 plus L4. And it turns out I can just copy and paste this whole thing down. And you see that my frequency, my cumulative frequency, matches the total number when I get to the very furthest right side. Or the furthest right I can go on this. The biggest value I have is 29. When I get there, I've got everybody's less than or equal to that age. Okay, so that's this idea of adding up probabilities as we go. Well, that's the idea of adding up the frequencies. But we can do the same thing with the relative frequencies. So we get a relative cumulative frequency, or cumulative relative frequency distribution. So we'll say in O1, we've got cumulative relative frequency distribution. So for this one, we're going to do exactly the same thing, except for we're going to add up the frequencies, the relative frequencies as we go. So we have this first one's equal to 5%, so O2 is equal to M2, and then I'm just going to copy and paste the cumulative frequency from column N over to column O, and that's going to just add those things up as we go. And I'll know that I've done it right when I get to the bottom, and the cumulative relative frequency is 100%. Okay, so if I were to ask you guys, what's the probability if I were to randomly select somebody from the class, what's the probability that they are 26 years old? What would you say? Say 0. Why is that? Because we don't have any 26-year-olds, okay? What if I said, what's the probability that somebody's 23 years old? What would you say? Well, I'd come over here to my chart, and I'd look up 23. Oh, 23, sorry. Still 0. Let's use 21. My mistake. What's the probability somebody randomly selected from class is 21? Well, it's 7%. Okay? Now, if I take that person out, and I believe there's a homework question about this, if I take that person out, and I'm going to select another person, does that probability change that they're 21, that somebody's 21? Yeah, it goes down because now I'm selecting from a population of size 54 instead of 55, and so that probability is going to change. Do I care about that? Does that make a difference? Yeah, well, it depends on the scenario. If I had instead of 55, if I had 5,000 students with the same proportions, and I take the first one out and it turns out they're 21, does that, taking that one out, does that change what's left? Yeah, it does, but it's such a small change that I don't have to worry about it. So in other words, instead of having 77.2727, maybe it's 7.27276. And the rule of thumb is if you have a sample size that is 5% of the population size or less, then you don't have to worry about anything that might happen like what I just described. Okay, so and I know there's a homework question that asks you to figure out what the population size is in order to get a sample that you can treat as coming from an infinite population. In other words, I have a finite population here. I've got 55. If I were to treat you guys like a population, if I were to randomly sample 2 or 3, the first one would have this distribution. The second would have a different distribution to sample from. And the third would have an even different distribution. But if I had a big enough population I'm sampling from, it doesn't matter. I don't have to really care about it or even think about that. Okay, so that's the cumulative relative frequency, and I can't emphasize enough how important this is. If I wanted to know the probability that somebody is more than, let's say, 20 years old, how would I find that probability? So let's actually come over here to our notes and write this down. So I want to know what's the probability that if I were to randomly select someone from the class, that what's the probability that their age is greater than 20 years old? How would I find that? Okay, you're right. I would say, well, this is 1 minus the probability that age is less than or equal to 19. Because probabilities have to add to 1 if you're taking the complement. So the complement of being greater than 20 means you're less than or equal to 20, not 19. Okay, so I would come over here and say, this is just the relative cumulative frequency. And I promise you, you're going to need this notion, this idea. So I come over here and say 20, its relative cumulative frequency is 83.63%. So this is going to be 1 minus 0.8363. And so think of it as if we had a curve, like a bell-shaped curve that looks like this, and I said, what's the probability of being bigger than 20? It's just the area under the curve up here. So the notion of the cumulative relative frequency means we're going to come down here and say, what's the probability of being less than 20? And we're going to subtract that from 1. So this, here we've got the probability age is less than or equal to 20. This right here is the relative cumulative frequency. And we're going to use it all the time. So if none of this makes sense, make sure you ask questions, talk to your friends about it, look it up in the textbook, make sure you understand in the homework what's going on, because this is really it's the basis for everything that we do in statistics. In fact, if you come back and look at the big picture, and we say if x bar is 950 and mu is 1,000, if we want to determine if that difference is big or not, the way we do that is by using cumulative relative frequencies. Okay, we have this notion, we say how close is x bar 950 to 1,000? We need to get that into a standardized form, which we will talk about now. and then we can use the distribution that goes along with x bar to measure the likelihood of being in that range. Okay, so let's look at, before we get there though, let's look at, I'm going to come down here to cell L18, and I'm going to type mean, and I'm going to type standard deviation, STDEV, and in cell M17 I'm going to put homework, and then N17 I've got TV. Let's see, what else do we have? Age, exercise, no, what was third? GPA. Age, exercise, grade, and gender. All right, so the mean for homework, can we calculate that? This is extremely useful to be able to do this in Excel. When you get to the homework problems, you can oftentimes download the data set in Excel and the function that you want to use. So in M18, I'm just going to say equals mean, MEAN, open parenthesis, and then I just need to go over here and find my data. So I'm going to go homework. So this is A2, and if I do Control Shift, I can jump all the way to the next break, which gives me 57. So but because I don't have the age for this person, I'm gonna leave that out. So I'm gonna start with the second one, and I'm gonna go all the way down, and then I just have to close the parentheses and push enter. And what is it like this? Because it doesn't like mean. Sorry, it's not mean, it's average. In Excel, it's average. Other software packages use mean. So I see that on average, you guys are watching 11.2 hours, or sorry, you're doing 11.2 hours of homework every week. Okay, so if I want to get the same thing for TV, since I've got relative formulas here, I can just copy this and paste it into TV. So N18, I just pasted what I had in M18, and I see that on average you guys are watching 10.39 hours of television per week. Now I can do the same thing for age. Sorry, that's GPA. Okay, so for GPA, I see your average GPA is 3.46, and then let's just delete this. I can find your average age, 19.7, the amount of time that you exercise per week. Now, can I take the average grade? I can try. What happens when I do? It says, hold on, there's a problem. You can't do that because there's no numbers in there, or at least there's things that are not numbers. So it doesn't make sense to look at the average for categorical data. Same thing for gender. Although I could, for gender, I could say what proportion, how many are there that are males versus female. The average function's not going to do that, so I'm not going to do that quite yet. Actually, I can do that very easily. If I use the function count, so I'm going to say an S18 count. Never mind. I'm not going to do that right now. It's not going to work like I'm expecting. So we'll leave those two variables for now. But if I want to know the standard deviation then for homework, how am I going to find that, do you think? Well, I could go back over here and use my calculator and plug in to this formula here to get the sample standard deviation. Treating you guys as a sample. If I wanted to treat you as a population, I would use the other formula. Is that fun to do for 56 data points? It's not. You don't want to do it. You're going to make a mistake if you're using a calculator. That's one reason why I highly recommend that you use Excel or some other statistical software package if you don't want to use Excel. Because if I do make a mistake, it's pretty easy to find where the mistake is and correct it just like that. I've got a record of it. If I'm putting it into my calculator, say like on an exam or something, or a quiz, if I'm putting it into my calculator and I make a mistake, I don't know where the mistake was, I don't know how far I'm off, and it's just much more difficult. So the function is stdev dot, I'm putting this in cell M19, stdev dot either P for population or S for sample. Now if I use dot P, that implies that I know what mu is. But when I do it in this function, it's just going to take the sample value. So the only difference between the dot S and the dot P is one divides by n, the other divides by n minus 1. So you want to be very careful you use the right one. And so now I'm going to go back over to my data and highlight the data points that I want to put in here. Since I'm not using this first one for homework, maybe I should be, but since I don't have the age on it, or since I'm missing something there. All right, what's going on here? Let me try this one more time. stdev.s, open parenthesis. I'm going to just come over here, scroll over. Control-Shift will select everything that's continuous. So I push Enter. And I see that the standard deviation is 8.65. So the mean is 11.2 hours. The standard deviation is 8.65. I'm going to copy and paste that for TV, for GPA, for age, and for exercise. And this is very informative to me. I can look at you guys and say, okay, homework's important. Looks like homework's more important than TV, you guys, which I'd say is good. If you were doing no television or no other sorts of activities that aren't homework, maybe that would say something as well. But if I want to be able to say, compared to the average student, where do you lie? How close are you to the mean? Well, I could come over here. This is the notion of standardizing data. I could come over here and say, all right, here's the first person. They do 3 hours of homework per week. I'm just going to, we'll leave it in, but 3 hours of homework per week, because we don't have their age here, we're going to leave this one out. 3 hours of homework per week. That's below average, right? Because the average is 11 point whatever it was. So how much below average is that? Is it close to the average? Well, that's a hard question. I mean, I can take the difference. It's 8 hours or so. But is that big or is that small? 8 hours. Well, if I compare that to the standard deviation, which is 8.65, how many standard deviations is that? Well, it's about 1 standard deviation, isn't it? Okay, so if I take my data and I put it into, let me insert a couple of, if I put it into this formula that says Z for homework, Z for homework is going to be equal to, so this is, I'm using H3, cell H3, I'm going to say 3, the homework for whoever that person is, minus, what am I going to put in here? Minus the mean, which is going to be 11.2. And then I'm going to divide that by standard deviation. So they have they're minus 0.94 standard deviations from the mean. So 9.4 standard deviations below the mean is the distance between this person who does 3 hours of homework and the average. Okay, so why would I go through the trouble of making this z value? Well, it's a standardized measurement. It allows me to make comparisons between their homework how much homework they do and how much TV they watch, right? Because they do 3 hours a week of both. I'm not sure what else they're doing, but they look like they're doing okay with a GPA. Maybe they're working, maybe they're who knows what. It looks like they're exercising a lot. Okay, but 3 hours of TV, is that more or less than the homework? Well, if you look at the absolute numbers, it's exactly the same, right? But if I calculate the z value for the TV, I'll find out something interesting. Z for TV, I'm just going to copy and paste. And I probably have the wrong number there. So let me fix this up before I do that. I want to keep the same column. Sorry, I want to keep the same row, but I want the column to change. So I'm going to put $sign on the 18 and a $sign on the 19. Now when I copy and paste this, okay, I get the same thing. So that works. So what this is doing here is it's saying give me B3, which is 3, subtract P18, divide by P19. So what's P18 and P19? Come over here and I see, oh, here's P18, which is 10.39, and P19 is 9.53. In other words, the average amount of TV watched is 10 hours 39.39 with a standard deviation of 9.53. So compared to everybody else, this person does minus 0.9 standard deviations of homework, and but they do less TV watching, even though it's the same amount of time, 3 hours. Compared to everybody else, their z-score is negative 0.77. So they're 0.77 standard deviations below the mean for television and 0.94 standard deviations below the mean for homework. So looks like we are out of time. I will post this Excel file on Blackboard as soon as the internet starts working again. And there's no class next week because of Columbus Day, so don't come here. Instead, make sure you watch the videos and be prepared to come the following week, where we're going to we'll review some of the stuff from next week, and so we'll see you then. If you have questions about the homework, please send me email.
I get it.